Okay, basically, let's call this angle alpha, and then this angle theta, just for easier explanation. So what do we have here? We have Fgx, we have force of friction, then we have what's it called, force normal, we also have Fg y, let's put it like that. Then this would be the applied force, okay? Fa, I'll just write it as Fa, I'm not gonna write applied. So here we have Fax, and here we have Fay, okay? Now, let's think of it like this. Fgx, I'll take left as positive and down as negative. I mean, down is positive, okay? So I'm just switching it because it'll be easier. But basically here I have Fgx pulling towards the left, okay? Positive. I also have Fax, this one, pulling towards the left. Then I have the force of friction pulling to the right, like this, okay? And that's why force of friction is negative, because it's going the opposite direction. And so this is all the forces that are acting on the block, okay? So Fgx just turns into Fg sine theta. Again, theta being here 19.4, and here it's being 18 degrees for alpha, okay? So alpha is 18 degrees, but yeah. Fgx, the x component, is just Fg sine theta. Fax, this part, is just Fa cos alpha, and then minus the force normal times mu, because that's force friction, okay? This 2 stays the same for now, so I just put like these quotation marks, and here we break this down into this. So here we have two forces acting, Fay, I mean Fgy going down like this, and in the opposite way we have F applied towards the y direction, okay? So this is going the opposite direction, so that's why I'm doing negative. And if you really think about it, like by pulling it slightly upwards, you're making it kind of lighter. Like it practically acts like as if it's lighter, but it being lighter means it has less force of friction. Okay, does that make sense? That's why I'm doing minus right now, because what's it called? Yeah, it's going in the opposite direction, and it makes the block lighter, which reduces the force of friction. Okay, and then Fg cos theta just stays the same, and Fay is Fa sine alpha, okay? This part here is Fa sine alpha. Force applied sine alpha, okay? And then we have mu. Then we distribute the mu, and like, okay, so we're looking for Fa, right? Fa and Fa. So we move that to the left side of the equation. But to move this to the left side of the equation, I have to open these brackets. To open these brackets, I move the mu like that. And very important, wait, I don't know why I have here. Very important is this minus sign. Because you see here, I did minus, minus, minus. So I also have to distribute the minus sign, okay? Oops. And then, yep, yeah. Then this becomes negative mu Fg cos theta, and the minus and minus cancel and make a plus, so plus mu F applied sine alpha. Then we move all the Fas, F force applied, to the left. So here we have it. So this becomes minus, and this becomes also minus. Okay, that's why here we have minus a negative mu fa sine alpha minus fa force applied cos alpha equals to whatever this is, which is the remainder. So I take out the fa, I make them alone because that's what we're looking for, and I also take out the negative to make it easier. So here, mu sine theta sine alpha plus cos alpha, they both become positive because I took out the negative as well, you see, so these become positive. Yeah, then I'm looking for fa, so obviously I'll move everything that's not fa on the right side. So here I divide it by this part, right over here, and then I also want to get rid of this negative, so I just multiply it by -1 and I put it here. So that's why there's a negative over here. But it also doesn't matter because we're going to be doing the, what's it called? Magnitude of this. So it doesn't matter, but just for the sake of calculation, we can just add it. So minus mg sine theta minus mu cos theta all over mu sine alpha plus cos alpha. And when we substitute it, it's minus 36.2 kilograms times 9.81 meters per second squared times sine, this is 19.4 minus, oh shit, I should have moved this. Wait. Okay, wait. Oops, sorry. You can just skip ahead. But yeah, we when we substitute the values, it's 36.2 kgs times 9.8 meters per second squared, and it's positive because right now I'm taking down as positive, times sine 19.4 minus 0.91 cos 19.4 all over by mu is 0.91 sine alpha being 18 plus cos alpha being also 18. So this, when I put this in the calculator, I got 151.4125, etc. Or rounding it off to 151.4 8 newtons. There you go. And that's how I got this answer. Just like the thing. And the logic behind this is that, as you can see, this FAY is pulling the block upwards, which makes the weight of the FGY lower. So this becomes smaller, kind of, because they kind of like cancel each other out, but FGY is still greater, okay? And that's why the force of friction is lower. So then technically the normal forces becomes lower, and therefore the force of friction becomes lower. And if you need less force of friction, that's why we also need less weight. I mean, we need less force to pull on it, right? Because it also becomes slightly lighter, kind of, and because of that, yeah, that's why we got a smaller answer than what we got before, 151, when before we got like 190, because the block was quote unquote heavier. And yeah.